So, Rich, today we're talking silver graphite dispersion coatings. Kind of in general, I know you all are working heavily with the automotive OEMs. Let me start from a basic for those who may not know. We know silver. Talk about graphite and dispersion. What exactly is that? How is it different in a way?
Sure. Well, our product line has, and the approach we've always taken is the use of metallurgical alloys to improve metal properties.
Hmm.
And although we have delved into dispersions, and we have a number of products that are dispersions on the nickel side, we have not, considered that strategy on the silver side. And so when we really evaluated the outcomes and what in the wish list that the automotive EV people were looking for, we started saying, will the alloys that we've come up with ever really solve that in a way that would really get them to make a change?
Right.
And what we found is that the risk reward just wasn't connecting with them. And so we
Hmm.
started thinking outside the box. And the natural progression when you're looking to make very significant property changes to metals is to at least consider the dispersion, a dispersion strategy.
Hmm.
And so that's what we've done. We've taken a look at what we can do to matrix the great conductive properties of silver, with the dispersion option.
Right.
Looked at a number of dispersion options that could do this, and then landed on a pretty common material, which is graphite.
Hmm.
The properties of graphite, which are pretty exciting, is that it has two things. It has great lubricity
Hmm.
and shedding properties for low friction, which is great. But it also allows us to preserve what everyone loves about silver, which is its conductivity.
Right.
And
I was going to say, let's talk specific. What type of parts in automotive are going to be used in this type of a process with the silver graphite dispersion? What are we talking about specifically?
so, originally we aimed the product because of that low friction. We aimed it at all connector applications.
Hmm.
And we got really great results on the number of insertions that we could achieve with a low friction material and a
Hmm.
self shedding material. So we caught great interest. But then we could see a little bit of a gleam in the automotive guys' eyes about the other properties where silver was coming up short. And where silver was coming up short is it recrystallizes at a fairly low temperature, which changes its properties. It does one of the properties that everyone has always been frustrated with silver is the fact that it tarnishes. So we're
Right.
all familiar with the sulfide interaction
Mm.
of it. And when that happens, that's a very stubborn oxide that changes contact resistance and all kinds of things. Plus the visual look of a tarnished silver,
Right.
just denotes failure,
Right.
problems, potential for electromigration, etc. And so, we could see that they were going other places that we had initially did not consider. So, on all of those fronts, when we really started looking at what a graphite silver dispersion could do, it really performed well in every one of the things I just mentioned,
Right.
beyond the improved insertion capability.
Right.
Uh,
It's funny is that like I said, you mentioned silver's been a mainstay for so long, right? You all work with the automotive makers and tiers very closely. To get them to look at any other type of product, it's got to be tough, right? They don't want to deviate from what they've had in the past, right? Is that a tough nut to crack with them?
Well, it's a very tough nut not to crack. They're essentially looking for major improvements and low and actually ask about lower costs. So what they want it all, right?
Right.
You know, and so for them to make a change, uh, any new product introduction engineer
Hmm.
or person associated with this, at least in his mind, is looking for gains of 5 to 10x in value, right?
Hmm.
Something that's just gonna be such a win they can't walk away, and
Right.
the risk of moving towards it is really worth it.
Mm.
You know, this is new product introduction 101. I think on day one of the professor's seminar to engineers, he talks about the power curve that it takes to get someone to consider a change when you look at all of these things.
Right.
You know,
Right. Yeah.
small incremental improvements and changes, you know, just never get accepted. The qualification period is too long,
Mm.
and if there aren't just such significant costs associated with it, it doesn't go anywhere, you know.
Right. And it's tough because I think you've got some requirements. Whether it's weldability, solderability, all these things that's got to go in and fit together. And again, that makes it tough because it's getting the distribution, the ductability, those type of things. It's something that takes a while to develop a product that'll meet those specs. It seems like.
Absolutely, and you have to do it in all three of our plating environments, right? It's got to be good for large rack parts, right?
Hmm.
It's got to be good for smaller barrel parts, and there's always you know, the fastest plating process, which is the reel to reel for connectors. They
Hmm.
want it to work in all three environments, you know,
Right.
in order to
Right.
make the greatest impact. So, and each of those environments, especially for dispersion, create a new set of challenges and difficulties. Rack
Right.
obviously being the easiest, and then incrementally more difficult as you move to barrel, and then to you know, high ASF reel to reel application.
Right. And not only does it take you to develop these products to meet those specs, but then the testing that involves, right? That's a kind of a long-winded process as well to really verify, to get it into a shop, to get it. Talk about that a little bit. That takes a while as well, I'm sure.
Yeah, well, you know, I have to say, it's very difficult for us to run, you know, full-fledged automotive testing, you know, to the degree that really proves a lot to automotive people,
Hmm.
because it's not just a matter of passing this ASTM or that ASTM spec. You know, you you know, you can take them and you sum them up into what you think is an impressive presentation, and then they come up with 5 or 6 other things that you never considered. For example, we never would have considered, you know, vibration and fretting as something that we really had the ability to measure well, you know. And
Right.
so the good news on a product like this and the problems that they are experiencing today is that this is one of the first times that I've seen that they've jumped in with us and
Mm.
helped us out with the testing.
Right. Right.
And the
Uh,
result is on specifically vibration, which we wasn't completely on our radar when we developed this particular product. You know, they were in the best position to do all of that testing for us and give us the results. And they've been incredibly proactive
mm.
in doing that. Where in the past, they have not really looked to invest as much. I think they're playing, you know, fast catch up, and that they realize that in the industry now, you know, they've got to move faster. You know, just
Right.
like all industries that have to, you know, move quicker and make decisions, sound decisions quickly. They are jumping in to help, and that's making a big difference for us.
Yeah, I was going to ask you what precipitated that kind of change. I know it's a couple. I think 2 years ago, I went out west to an anodizing class just to sit in and watch it. And there was a couple automotive engineers there who
Mm.
took the class, and I remember them telling me they were amazed at they did not know enough about surface
Yeah.
finishing, and and they were kind of encouraging the company was encouraging them to get involved in it. But what do you see that? I mean, like I said, is that are they you're getting newer people into the industry, the automotive industry, engineers and such? Are they being a little bit more open minded? Do you think about that of really working closer instead of just telling you what they want and hoping you can come up with it?
Yeah,
But
the new breed is definitely more open minded. It just like anything else, it comes from an inexperience to be open minded and not jaded, right? So
right,
they're willing to turn over rocks that other people have said, "Don't worry, that rock does not have merit. We've been there before." But the truth is that all the rules have changed now.
mm,
You know,
right, right,
and it's changed in almost every part of the car, to what was a mechanical, powertrain now being a fully electrical, right?
right, right,
Electronic powertrain, sealed with heat,
mm,
temperatures have risen, for where they try to keep it under 130 to 150, 160.
mm,
There are new parameters,
right,
and when the rules change on their side, that requires them to adapt.
right, right.
And
Yep,
the companies that are going to be successful are the ones that go back, into their engineering experts that have been around for a while, and ask them some real tough questions, in terms of how to solve those things.
right,
And I do have to say that some of the older, more experienced engineers have really come forward on us and cozied up to some new, some new ways of doing things, and that's been tremendously refreshing.
right.
Uh, you know, uh,
Yeah, I was gonna say it's got to be that they're more open and collaborative to that. I've heard that from a couple of the end user players who are talking about they're having these discussions with not just automotive but anything where they're being asked early on in design what to look at the design for them and give them feedback and say where could be some problems with that.
uh,
Uh, so let's talk. So Uyemura, you all are working on a product. Like I said, it's going to be launching later. I don't know how much you can tell us about it. And give us first of all, give us an idea of how long it took really to really develop this product and to get it to where you want it, and then what's
yeah.
the timeline you think you'll be bringing that to market?
Yeah, well, these things are in the lab for always more. It seems like more than 5 years, in concept
Right.
and stuff. But we've been hands on with the product, for over 3 years.
Hmm.
The best way to do it is almost always to get these prototypes, in influential people's, hands, or the guys that are working on some really tough problems,
Mm.
and then find a beta application,
Right. Right.
for it. So once the property is approved, which we're well past, that stage, we really, so we're way past proof of principle. We are really entering pilot production,
Mm.
and so we literally have live POs and are installing North America, capability, actually this month,
Oh, gotcha.
in the
Okay.
Northeast, and so that'll be announced. That particular North American production,
Right.
will be announced. So the ability to produce parts, and
Right.
again, we have a PO in hand, from a major supplier, for a specific application.
Right.
Again, interesting to us, the problem that was addressed with this particular, part number was, improved vibration and
Hmm.
resistance, to mechanical, fretting and vibration failure.
Wow. Okay.
Yeah. So,
So
again, you never you develop these things, and you aim it at solving a particular problem, and then almost always, these new applications come up where it's, tremendously interesting, and it wasn't necessarily on the radar at first.
right. It's funny when you developed, like I said, this product that you're all going to be coming out with, and I guess every time you make that step of meeting specs and is it easier for the next time around, or is it still not? Is it still a challenge to really, now the next time you get a request by the OEMs to do certain things and meet certain specs, or is it?
Well, that's a great question. I think it has a lot to do with credibility.
Mhm,
I wish I could tell you that 4 or 5 years ago we were well entrenched, and in automotive that was not the case. We
mhm,
weren't really completely the new guys, and we were very much a curiosity without having a particular case study that was a major win for
mm,
us.
right.
We did some really impressive work on satin nickel for years, and a lot of things that everybody knew. You should talk to those guys. They'll be very interesting to
Hmm.
talk to, and they'll have an interesting approach.
Right.
We are hoping with what's been put together on this program, since we have a high confidence and a very high belief that it will be successful, that will be the credibility that more people will want to work with. We're certainly, as you mentioned, have a better understanding about testing requirements
Hmm.
and how to get further along quickly
Right.
in our own investigations. So we've laid out our applied development group a little bit differently in terms of the early outcomes that we're looking for and such. And
Gotcha.
we're getting better guidance. You know, there
Right.
was
Right.
a time when guidance had the potential to give up intellectual property
Right.
or direction, or and keep it close, kind of thing.
Right.
I think there's a general trend through NDAs and keeping it to a small group, that the trust is greater and the information transfer has improved quite a bit.